So today we're going to talk about infinite limits as x approaches some value. Okay, this just means we're talking about vertical asymptotes. So in some instances, okay, we will have something like the limit as x approaches 2 of our function equals infinity, or negative infinity. And if we're going up forever, it's positive infinity. If we're going down forever, it's negative infinity. Okay? Now, this is kind of an extension of what we talked about in the last section. Okay? We said whenever something like this happened, okay, if we had a function and we plugged in our value here and we got 2 over 0, okay, we just said the limit does not exist. Okay? Now we're going to take that a step further, okay, and say, well, it could be positive infinity or negative infinity. Right? So let's jump right into an example here. Okay, let's take a look at this function. Okay, 8 over 4 minus x squared. So we'll start graphically. Right? The graph of this function looks like this. The graph of this function looks like this. So what we can do, okay, we can talk about the limits, okay, as x approaches 2 and negative 2. Right? That's where we have asymptotes. Right? This should be a dotted line to signify an asymptote, not a solid line. It makes it look like it's part of the function. Right? So we can talk about what happens as we get closer and closer to those values. Okay, so if we think about as we're getting closer and closer to negative 2, okay, well, from the left, as I get closer and closer to negative 2 from the left, I'm going to negative infinity, and I'm going down. As I get closer and closer to negative 2 from the right, I'm going to positive infinity. Okay, so we can express our limits like this. Right? We can say the limit as x approaches negative 2 from the left of this function is negative infinity. It's just going down forever. Same thing as we approach negative 2 from the right. Right? It is going to positive infinity. Right? What about over here? What if we wanted to talk about the same thing as we approach positive 2? Right? So what if I said the limit as x approaches positive 2 from the left? So for this graph, if I said the limit as x approaches positive 2 from the left, yeah, that would be positive infinity. Right? How about as x approaches positive 2 from the right? Negative infinity. Right?
Oh.
Right? So, I mean, these are just kind of putting the symbols into sentences. Right? So we don't need to worry about writing out these sentences. What we're more concerned with is the notation down here. Right? Just saying the limit as x approaches these asymptotes from the left and from the right could be positive or negative infinity. Now, what if I asked you, what's the limit as x approaches negative 2? That does not exist. Okay? Why would that not exist? We said the limit as x approaches negative 2, and I'll just write of our function of f of x. Why does that not exist? Well, but the one-sided limit exists, right? We can say it goes to negative infinity from the left, or from the right it goes to positive infinity. So why? So what is this saying as x approaches negative 2? That's the two-sided limit, right? So since the two-sided limit, right, they're not approaching the same value, that's why it doesn't exist. Okay, from the left, we're going to negative infinity, and from the right, we're going to positive infinity. Those two values, okay, even though infinity isn't a value, okay, those two limits are not equal. Therefore, the two-sided limit doesn't exist. Okay, we can say the same thing for the limit as x approaches positive 2. Right? That limit would not exist either because our one-sided limits are not equal. Okay. Good so far? All right. Actually, before we do this, let me do another example with that idea here. Let's take a look at the function 1 over x squared, right? So this function looks like this, right? This is what 1 over x squared looks like. It has a vertical asymptote at 0. So here, if I said the limit as x approaches 0 from the left, what would that be? Positive infinity. How about the limit as x approaches 0 from the right? Positive infinity. So what about the limit as x approaches 0? Right, the two-sided limit does exist in this case, okay, because my one-sided limits are equal to each other. They're both equal to positive infinity. Therefore, we can say the two-sided limit does exist in this case. Right? Both the one-sided limits are approaching the same thing. They're both approaching positive infinity. So the two-sided limit does exist here. Okay. Any questions so far? All right. Then let's get back to this. Okay. So now let's get into a little bit of algebra, and hopefully this rings some bells from last year a little bit. Okay. I know you worked with rational functions and you found horizontal and vertical asymptotes. So if we are just given a function without a graph, okay, we want to find where vertical asymptotes are. Well, first thing we need to do is cancel out. I guess I forgot to add and cancel common factors. Right? Factor numerator and denominator and cancel any common factors between them. Right? Then set the denominator equal to 0. Wherever the denominator equals 0 of a rational function is where we get an asymptote. Okay? So let's take a look at this first one here. I've got 2 over x plus 3. So first step, I'm going to factor the numerator and denominator and cancel any common factors. Well, in this case, there are none. Right? There's no factoring to be done. There's nothing to cancel. So I can just go right to step 2, set the denominator equal to 0. So subtract 3 over, I get x equals -3. And pretty straightforward. That tells me that this function has a vertical asymptote at -3. I have a vertical asymptote at -3. And so in a second, we'll talk about how to find the limits as we approach -3 from the left and from the right. Okay, but for now, just take a look at finding asymptotes. Okay. So are we okay with that one? All right, how about the second one? Okay, you guys go ahead and try the second one. So did we get that we have a vertical asymptote at x equals -1 here? Okay, good. So what about this x minus 2? Okay. We canceled out that factor. Okay, but what happens on the graph at 2? Okay, we know that at -1 there's going to be an asymptote. But what happens on the graph of this function at 2? Something weird does happen. There's a hole. Exactly. Okay. And we'll talk a lot more about this in the next section when we talk about continuity. Okay, but whenever something like this happens, or whenever we cancel out factors like that, there will be a hole in the graph. Right? So maybe make a note, right, that this means hole at 2. Okay? We're not going to do too much with that right now. In the next section, we'll do a lot more. All right, so for both of these functions, we've found their asymptotes. Okay, so let's take this a step further now into calculus and talk about, well, what happens as we get closer and closer to -3 for this first function. Right? So for this first function, I want to find the limit as x approaches -3 from the left, and the limit as x approaches -3 from the right. What do you guys think? How should we do that? Any ideas? We know that it's going to be either positive infinity or negative infinity, right? We know that much because we know it's an asymptote. But how would we figure out which one it is? Right? Is this going to be positive or negative infinity? Is this going to be positive or negative infinity? And I think that's going to be the easiest way to do it. Right? Is just plug in some values, right? Make a little table on each side. Right? If we're doing this by hand, that's going to be the easiest way to do it. And obviously, if we have a calculator and we can just graph it, that would be even easier. But if we are required to do this by hand, okay, the easiest thing to do is going to be to make a little table. So if first I want to find values as I get closer and closer to -3, what values should I choose here? Sure, -2.9 would be a good one to start with. And so, yeah, sure. That will definitely keep getting us closer and closer. Right? So if I plug -2.9 in here, well, I'll go ahead and write it all out first. I get 2 over -2.9 plus 3. So -2.9 plus 3 is 0.1. So 2 over 0.1. What's 2 divided by 0.1? 2 divided by 1 would be 2. It's 20. Right, 2 divided by 0.1 would be 20. So then let me move this down a little bit. So let's take our next value, -2.99. Plug that in. So -2.99 plus 3 would get me 2 over 0.01. And that would be 200. Good job. All right. So, I mean, we could try another one. We could do -2.999. Right? But I think it's pretty clear what's happening. Right? It's going up. It's going to positive infinity. So let's do the same thing then to find the value as we're coming from the other side. So what values should we choose if we want to figure out the limit as x approaches -3 from the right? Sure. Let's do 3.01. So if we plug 3.01, or -3.01, yeah. So if we plug in -3.01, get 2 over -0.01, -200. Right? And then we could plug in, since we did 0.01, we could do 0.001 to get something even closer. 0.001 plus 3 would get me 2 over negative 0.001. That would be negative 2,000. But
I think you put the infinity in the wrong one. Isn't the possibility visible word?
oh yeah, right. I did, didn't I?
That doesn't make sense.
Yep. Thank you. Negative 3.
I was just writing it down and it's like, wait. But negative 2.9 is bigger than negative 3. Wait, okay.
You are correct. Alright, so then negative 3 from the left, right, is the second table we made, and that is obviously going down. Okay? So doing this by hand, the easiest thing to do is just going to be to make a small table, right? Choose a couple of values, getting really, really close to the value that we want. Okay? Now, if we do have access to a graphing calculator, then just plug this into y equals and look at the picture. Right? That'll definitely be easier. On the AP test, I guess we can start talking about that. Half of it is non-calculator, half of it is calculator. Okay, that's how the AP test works.
Oh, that's
So it's all Mr. Boldazar's fault. Right. So yeah, it's half of the test is non-calculator, half of the test is calculator. So a lot of the things we do in here will be non-calculator, right? Especially chapter tests, right? A lot of the tests that we do will be non-calculator because you have to get used to not having a calculator on the AP test. Right? We will certainly do things that require a calculator as well, right? But that's why we're going to be doing things like this by hand, right? Because we're not going to have access to a calculator for half of the AP test. Right? So, questions on this process? Alright, then you guys try this second one here. Okay? Tell me, I guess I should have made these two different functions. I should have made this g. Right? Tell me the limits as g of x approaches negative 1 from the left and negative 1 from the right. So when you are plugging in these values, you can plug them into the simplified version. Right? You can just plug them into 1 over x plus 1. Okay? You don't have to plug them into the original function. what did we get here? What's the limit as x approaches -1 from the left? Positive infinity? Is that what everybody got? Nobody else is giving an answer.
I don't know.
I get wrong like 5.
Well, nobody is wanting to venture an answer. Maybe we should do this one.
And then the next one's negative. And then 1 is 1.
Right, so then the two-sided limit wouldn't exist. Alright, so from the left, right, if we want to choose values to the left of -1, right, that would be like -1.1 or -1.01. Okay, so if I plug those values in, so 1 over -1.1 plus 1 get me 1 over -0.1, -10. If I plug in -1.01, that would get me 1 over -0.01, be -100. So as we get closer and closer to -1 from the left, I think that's going to be negative. Right, then if we do the same thing for values getting closer and closer to -1 from the right, so we can do -0.9 or -0.99. So if I plug those in, 1 over -0.9 plus 1 would get me 1 over +0.1. Here, -0.99 plus 1 is 1 over 0.01. So that would get me 100. Yeah, so with negatives, that is tricky, right? Because you have to think numbers that are further into the negatives are to the left of -1, right? So -1.1 would be coming from the left. Right? So then, as Sharon already said, the two-sided limit would not exist here, right? Now, if I got negative infinity for this first one, does that automatically mean the second one's positive infinity?
No.
No. Right? I mean, we looked at a graph where that wasn't the case, where they both went to positive infinity, right? So just because one's negative doesn't mean we can not check the second one. Right? We have to check both of them to see which direction both one-sided limits are going. Right? Questions? All right. That is pretty much it for today.
Okay.
Okay?